section 4.4 SSS, and what the SSS stands for is side, side, side. We'll start this section with a postulate. Now remember, postulates are things that we know just have to be true. So postulate number 19 is the side, 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 or SSS congruence postulate. It states if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. Previously, we knew in order to prove that two triangles are congruent, we had to prove all three side pairs are congruent and all three angle pairs are congruent. So this postulate gives us our first shortcut. If we can prove that all three sides of one triangle are congruent to all three sides of a second triangle, then those two triangles are congruent. So if you see here in this diagram, we are shown that segment AB is congruent to segment RS. That's our first pair. Then we're shown that segment BC is congruent to segment ST. So there's our second pair of congruent sides. And then we are shown that segment CA is congruent to segment TR. So there's our third pair of congruent sides. Since we know that all three sides, side, 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 that's what the S's stand for, since we know all three sides are congruent, then we can state that triangle ABC is congruent to triangle RST. Let's start with example number 1. And example number 1 puts the side, side, side postulate to work. We are asked to prove that triangle ABD, which is this triangle right here, is congruent to triangle CDB. So that's this triangle right here. So looking at the diagram, we are told that segment AD is congruent to segment CB, and we are told that AB is congruent to CD. So let's write that first. Again, the first thing we are told is segment AD is congruent to, and I'm going to write it in corresponding order. A and D show up first and last in our proof statement, so I'm going to do C and B in that order. So segment AD is congruent to segment CB, and we know that because it was given. Next, I know that this segment is congruent to this segment. And again, I need to write it in corresponding order. So if I'm going to name this AB, those are the first two letters, then I'm going to call this segment CD, since it's the first two letters in our second triangle. So again, I'm going to write AB, segment AB is congruent to segment CD. And again, I know that because it was given in the diagram. So let's just assess what we have here. So far, we have two side pairs congruent. So I have this pair of sides congruent, and I have this pair of sides congruent. I need a third pair of sides congruent. So looking at our diagram, I see that this segment is shared by the two triangles. I have segment BD right here and segment DB right here. And again, that segment is the same segment. So a segment is congruent to itself. So I can get my third segment pair by stating that this segment is congruent to itself. But again, I'm going to write it in corresponding order. So if it's BD on this side, that corresponds to DB on the other side. So again, I'm going to write it as segment BD is congruent to segment DB, and that's the same segment. And I know a segment's congruent to itself because of the reflexive property. I'm just going to abbreviate that as prop. So since I know that this segment's congruent to itself, that gives me my third side pair that I needed in order to use the side, side, side postulate. So now I'm ready to make my proof statement. I now know that triangle ABD is congruent to triangle CDB, and I know this because of the side, side, side postulate. And I can just leave it as SSS. I could put postulate afterwards, but we all know that SSS means the side, side, side postulate. So to show that I'm done with this proof, I'm going to put my two tick marks to show that I am done. Example number 2 has us using the side, side postulate some more. It says, decide whether the congruent statement is true, explain your reasoning. So part A says, is triangle DFG congruent to triangle HJK? So we have DFG congruent to HJK. So we see that DG is congruent to HK. We see that DF is congruent to HJ. And we see that FG is congruent to JK. Since I have 3 pairs of congruent sides, I can say yes, this statement is true because of the side-side-side postulate. Part B says triangle ACB is congruent to triangle CAD. So ACB is this triangle, and then I have CAD. So I need to show that all 3 sides are congruent, so I can use the side-side-side postulate. So I see here that BC is congruent to AD. This segment is shared by the 2 triangles, so it'd be congruent to itself. However, AB is not congruent to CD since it's 3 over here and 4 over here. So this congruent statement is false. So my answer would be no, all 3 sides are not congruent. And now let's look at part C. It states that triangle QPT, which is this triangle right here, is congruent to triangle RST, which is this triangle right here. So let's see if we have all 3 side pairs congruent. So I see that QT is congruent to RT, QP is congruent to RS, and PT is congruent to ST. So in this case, I do have 3 pairs of congruent sides, so I can say that yes, this is true because of side-side-side, just like I did for part A. Example number 3, show that the coordinates of the vertices of triangle ABC, where A is at 5, 1, B is at -1, -6, and C is at 5, -6, is congruent to triangle XYZ. So notice they only gave us a picture of triangle XYZ. We don't have a picture of triangle ABC. However, if I have the side-side-side congruence postulate, I can find the lengths of all 3 sides of triangle ABC using the distance formula and compare those to triangle XYZ that I'm given over here, so that I can see if all 3 sides from triangle ABC are congruent to all 3 sides of triangle XYZ. So first, let's get to work at using the distance formula to find the lengths of all 3 sides of triangle ABC. So let's first find the length of segment AB. So again, I'm going to use the distance formula. Here's a reminder of what the distance formula is. The distance formula is equal to the square root of, I'm going to subtract the x's, and then square it. Then I'm going to subtract the y's, and then square that difference. So let's do AB. So I would have the square root of 5 minus -1 squared plus 1 minus -6 squared. 5 minus -1 is plus 1, so that'd be 6, and 6 squared is 36. 1 minus -6 is plus +6. 1 plus 6 is 7, and 7 squared is 49. 36 plus 49 is 85, and the square root of 85 is about 9.2 units. Let's now find the length between B and C. So I have the square root of -1 minus 5 squared plus -6 minus -6 squared. So -1 minus 5 is -6. -6 squared is 36. And -6 plus +6 is 0, and 0 squared is 0. So the square root of 36 is just simply 6. And finally, let's find the distance between A and C. So I'll take the x's, 5 minus 5, subtract them and square them, plus take the y's, subtract them and square them. So 1 minus -6. 5 minus 5 is 0. 0 squared is 0. 1 plus +6 is 7, and 7 squared is 49. The square root of 49 is 7. So I have all 3 lengths of all 3 sides. Now let's look at triangle XYZ and compare all of those lengths of those 3 sides to see if I get the same 3 lengths from triangle ABC. So this one actually makes it easy because I have a horizontal line and a vertical line, so I can just count units. So counting the units between x and z, I get 1, 2, 3, 4, 5, 6, 7. So side xz is 7. So that means segment xz is congruent to segment AC. Next, let's count the number of units between x and y. So I have 1, 2, 3, 4, 5, 6. So therefore, xy would be congruent to BC. I cannot assume that just because these two sides were congruent to these two sides, that the third side is automatically congruent. However, I cannot count units between y and z since that's a diagonal line. So I'm actually going to have to use the distance formula one more time. So I'm just going to slide this up so I have a little more room, and I'm going to find the length of, or the distance between, y and z. So again, I'm going to use the distance formula one last time. The ordered pair at y was to the left 1, 2, 3, and up 2. So I have -3, 2. And the ordered pair for z is over to the right 1, 2, 3, 4, and down 1, 2, 3, 4. So I have 4, -4. So using the distance formula, I would have subtract the x's, so that'd be 4 minus -3 squared, plus subtract the y's, -4 minus 2 squared. So I would end up with 4 minus -3 is plus positive 3, so 4 plus 3 is 7, 7 squared is 49. Then I have -4 minus 2, which is -6. -6 squared is 36. And 49 plus 36 is 85. And as we saw before, the square root of 85 is about 9.2. So therefore, now we can state that segment YZ is congruent to segment AB. So now I see that all three sides are congruent. So now I have shown that triangle ABC is congruent to triangle XYZ because of side, side, side. And that's it for this section. Make sure you jot down anything you don't understand that we can cover in class before we move on, and we'll see you then.